All right. Hello, everyone. This is the practical AI presentation. So, over the course of the last two quarters, we've gone mostly into the more theoretical or the theoretical concepts behind what is ML, what is deep learning, and what are the specific models that can be used to accomplish things. How can we do data analysis? How can we do LM fine tuning? And what are these specific models, right? But we haven't really gotten into how we can actually use them. So this is what I want to get into. Clicker, please. No, the clicker. Uh, nope. Oh well. Uh, Useless clicker. So why are we learning about ML? It's it's pretty easy to say like, oh, it's computationally expensive. It's really annoying to implement and debug, right? And very, very, very often, much more often than not, collecting data will be very expensive and often take up a lot of memory in your computer. It's inconvenient. And on top of that, training ML models will likely require specialized hardware on top of being very computationally expensive and very time consuming. On top of that, ML models, once implemented, are uninterpretable. That means that it's very hard to figure out why they make the decisions they do once they've made their decisions. And as such, they cannot be made accountable for the decisions that they've made. And the people who program these models cannot be made accountable for the decisions that the models make. So as such, it's pretty easy to believe that all this AI stuff is a bunch of baloney, right? Um, but we can. There's one thing that's very, very useful about it, which is it can automate complex tasks that normally requires humans to do. So, for example, we can use computer vision to label food, right? Or we can use computer vision to figure out is that person or is that a person on the street or is that a light? Or we can use text generation to essentially reason, right? When before only humans were able to reason. Oh, this is the new clicker, guys. This is a does a lot of clicking though. Um, so in that case, ML models are incredibly useful for us, and that's the one saving grace that ML has. But we can use this to a pretty good end. So, oh, and also, there's a lot of research that's been happening in using ML lately. If any of you have been paying attention to the Nobel Prizes, I think last year, one of a bunch of them were given to people who made innovations in their respective fields using advanced neural networks or just deep learning models in general, like AlphaFold 3. I think there was something related to economics. I'm not sure. But there were multiple Nobel Prizes awarded to those who made ML models or deep learning models that are extremely robust and very usable, very effective. So, oh, wait, did it go back? Oh, well. Oh, well. So, on top of that, a lot of other fields, just in general and not just tech, have hit a sort of plateau, which means that it's been very slow for academic or industry breakthroughs to happen, which means that we can use AI as a new paradigm to analyze why or how we can make or use different solutions to do things more effectively. So recently, within the last 10 years, there have been, for example, breakthroughs in autonomous vehicles where computer vision has gotten far better, meaning that self-driving cars are becoming closer. LLMs over the last 7 years have obviously gotten far, far better, meaning a lot of things, a lot of automating, a lot of ramifications in the professional world and the academic world, and much more. So far, this is just an abridged list, but we've gone over advanced neural networks, RNNs and LSTMs, transformers, a little bit into LLMs, and of course, many classical ML models such as KNNs and, of course, other things. And also, we've gone over Q learning and RL. So, how can we apply what we've learned? What we've learned so far is almost entirely very, very abstract. So you're probably wondering, what can we do here? Projects. We can make stuff. So how do we do that? It's very tempting when you're first making a project to just press Control C and Control V on the first model that you might find on wherever, perhaps like medium.com or something, or wherever you're getting your sources of information from. But the thing is, it can be hard to learn. And if you don't debug your models and if you don't make your models very fine tuned for the task that you want it to do, it's going to be hard to get anything out of it. But there are a lot of very good, very, very good pre-trained models on Hugging Face, for example. Hugging Face is just one source that you can find open source models from, but you can look up more in your free time uh, and find some usable ones. And a lot of the time, the open source models that are hosted on places like Hugging Face are very effective. And if you know what you're doing, if you know the theory, you can more easily use them for your own ends. Data sets on Kaggle also are quite useful, as you might have learned by now. But you may need to make your own. And the OpenAI API is sort of what everyone resorts to nowadays when they want to make an AI application. But there's a good reason for that. Hosting or using an LLM API on your own web app can be very effective, because if you don't just think of ChatGPT as just a chatbot that you can use to interact with users, you can find that there are a lot of unique applications that can be very, very effective, actually, much more effective than previous methods. And I'll probably go over that, or one example that I've used or made in my time. So if you want to create a project, you need really, really, really need to think about who will use your project. This is not only for an ML project, but also for web dev in general, right? You need to think about, okay, who is going to use my project? Has my idea already been implemented in the real world? If so, how can I make it better? And if my idea hasn't been made before, or if I really want to implement my idea, if people use it, how can I scale it up? How can I make it maintainable? How can I make it so that if many people want to use my website, it won't crash, right? So here's some tips. Your idea doesn't have to be that creative. As I said, if there's an idea that you have that you find out has already been executed, that actually doesn't really matter. If you know that you can execute it better than anyone else has, then your idea is probably going to get more users if you market it well. On top of that, if you have really good UI, really easy to use UI, you're probably going to be pretty good. Your website might do well, or your project might do well. On top of that, well-informed model implementation. So if you use a state-of-the-art or very computationally inexpensive model, right? Then your website or your project may be more easily scalable or more effective or more accurate or more robust or more generalizable or users' needs, which means that your idea might be really good. And of course, as I said before, OpenAI API. If you don't have any ideas, you could just make a chatbot and try to get creative with it. I don't know. But I recommend you try to get creative. And in order to get creative, you have to have a really good tool set. So that means you're going to have a decent understanding of how ML works conceptually and have a good toolbox of models that you can draw from. On top of that, maybe you might want to consider reading some survey papers about state of the art in the certain general field you might want to apply ML models to, right? And on top of that, you might want to uh, think about researching open source foundation models that are currently state of the art that you might be able to use on your project or your web app. So, how do I start? So, this is how you brainstorm. Boom, right? Look for problems that you have. This is a really easy, really easy way to find a problem that can be solved. Like, think of a problem that you have right now, and you can probably try to fix it. You could maybe use it not using or fix it not using ML, or you could try to fix it using ML. It may be hard either way, but if you get to into the mindset of dealing with problems, not by ignoring them or dealing with them, but instead solving them, that will make you a much better engineer in general. Next, what are you interested in? So there are a lot of topics that you might be interested in, right, for developing a project. And I'm not just talking about machine learning in general, but just web development in general, or just an app in general. You could be you could be thinking about like Pokemon cards, right? Like just off the top of my head, a computer vision model to recognize the value of a Pokemon card. That might be interesting. There's probably a data set for that, right? Or what kind of plant is this? You could probably make a computer vision model to recognize generally what kind of plant that is. Or you can implement a little chatbot or something to talk about a specific topic that you're interested in, right? So there are a lot of possibilities as long as you're creative. Um, and then you want to narrow it down to a specific problem, right? So you're going to want to narrow it down to a specific problem, mostly because if your idea is way too vague, you will never be able to see or evaluate your progress. Because if your if your problem isn't that easy to say, oh, I've achieved this, then you'll never know when to stop working on your project, or if your project was even a good idea in the first place. Additionally, if you don't know what your specific problem is that you want to solve, then it's going to be hard to implement it. And it's going to be hard for users to see what the point in your project is in the first place. So then you want to put together a tech stack. So if you want to implement a web dev project, then you're probably going to want to know where to host it, right? Or how to host it, what frameworks you'll be using. So maybe like on top of base JavaScript, you might want to use React or something if you're doing web dev. And you're going to be wanting to know what kind of ML models you'll be using, right? These are very basic considerations, and you'll likely go much deeper than that if you want to make a really nice, robust project. Or you can do it really simply. Who knows? Then you just put it together. So this is obviously the hard part. Implementing the solution, executing an idea always is very hard, mostly because you're going to run into a lot of problems along the way, things that were unexpected or things that you didn't account for, edge cases, or difficulties gathering enough data for training, or something wrong fundamentally with your idea that you might have to scrap the entire idea and or rework it for something else. Or maybe your idea is really good because You just knew what you were doing in the first place, and you brainstormed very well. And you have, uh, but that often doesn't happen. So here are the applications that you can use it for, um, or make a project for. This is just to get you started, but um, very good place to start would be education. I made a educational app with a team. I might talk about that in a bit. Perhaps robotics. Robotics is pretty hot. Web apps, as I've said. Maybe you can make something to do with autonomous vehicles or computer vision in general, or you can do something related to healthcare or biology. Who knows, right? Or sustainability, right? Or something related to energy. How can we better allocate energy use? So, or perhaps productivity, right? Maybe you could, if you're really ambitious, you could perhaps put together an AI agent that automatically does things on your computer for you so you don't have to do it if you don't feel like it. I've seen examples of those before. They're pretty cool. So all you really need to do is hone in on something you like and find an idea that you like and make sure that you have enough data, and then you can probably get started. Uh, yeah. So another thing you could do, another useful thing you can do related to AI is research. Research, research, research. This is a university. This is an R1 university. This is a UC. That means there are a lot of professors here doing research and a lot of funding going into that research. And on top of that, this is a university with a lot of CS related with a lot of funding for CS, more like. There are a lot of labs here for that are related to CS, and on top of that, there are a lot of labs here for uh, deep learning and machine learning related research. This is all to say that you can find research that you'll probably be at least a little bit interested in if you go looking. And as long as you feel like you know what you're doing, if you're well motivated, then you can probably find something worth doing if you're into it. So, why would you waste all that time slogging away trying to write a paper, right? Here are some perhaps good or noble reasons why you can contribute to human knowledge. You can create something that advances the field, put your name out there. Who knows, right? Have something to put on your resume and learn. If you do research, I can guarantee you on my life that you will learn quite a bit. It's absolutely 100% guarantee. As long as you put the effort in, I will guarantee you on my life. So yeah, and it's fun. Personally, I find it fun. Well, fun is very, very what's the word? Very personal. So perhaps you might not find it fun, or perhaps you will find it more fun than I do. Who knows? But you'd have to try it to know. So uh, this is just some advice on how to get going. So in from what I've learned so far, this is what a PI told me a while ago. There are three pillars to uh, a really good paper, right? If your paper has only two of these, or perhaps only even one of these, then it'll probably get published. So the first thing is motivation. Motivation is essentially what is your paper really trying to do? What is your paper trying to solve? What problem is there that needs to be addressed, right? So a good and well-motivated paper addresses an open-ended problem in the field, right? So let's say, for example, there's a problem with some sort of computing, right? Or training a model. It's really, really expensive. It's really, really time consuming to train a certain type of model for this certain type of task. So maybe a researcher might take it upon themselves to figure out why and how to do it more efficiently. and maybe using a lot of fancy math or some specialized hardware, they figure out, hey, this is I can do it better now. So they publish that, and it probably will get published to a pretty good conference. Another way to be well motivated or introduce novelty is to have a new perspective that's different from old approaches. So perhaps a paper might be very groundbreaking because not because it's very technically rigorous or that its solution was so well implemented, but the idea behind the paper itself was really, really new. No one really thought of that before. So it establishes a new way of thinking, a new framework that people can abide by. And by doing that, that advances the field, even if the paper's implementation itself wasn't that good. So this is technical rigor, the second thing. So technical rigor is essentially just how good is your implementation. So a very technically well-engineered paper could have really, really good results compared to what's been considered the benchmark at the time, right? So if a new implementation of a old model like just blasts everything out of the water, then that paper will probably be quite well regarded in the field, right? Or if your paper is really easy to implement or reproduce, right, then it's more likely that people will want to cite your paper and want to use your work. And then it is more likely to get cited more and more likely to get published to a good conference. And very importantly, maybe your solution is very, very well engineered, very, very effective, right? Or perhaps has just a tiny bit of novelty from established practices, but is really, really well put together so that essentially everyone wants to do the technique you're doing now. But that's just one thing. And then last is pretty simple, actually. It's just writing. I think anyone can do writing, or anyone can knows how to write in here, right? So all writing means is how easy to understand is your paper? How well can a person who isn't that familiar with the field understand what you're doing, right? Are you explaining your thoughts well? Is your logical reasoning correct? Does it make sense? Do your visuals make sense? Can I understand your visuals after like looking at it once? If so, then your paper is probably pretty well written. And that means it's more likely to get cited. It's more likely to get used, and it's more likely to get published to a good conference if the person reading your paper and judging your paper can understand what's going on. Because maybe in your high school, your English teacher probably wanted you to use a lot of big, fancy $5 words, right? But unfortunately, that isn't really what's good. That doesn't constitute good communication. Good communication is concise, it's easy to understand, it's clear, it's short. That's all you need to know about writing. So, this is a very, 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 very high level approach to doing research. To start out with, you got to read papers and find where other people left off. So often you'll see the phrase, we leave X for future work, some variation of that. If a paper or its authors didn't really accomplish what they were exactly trying to find out. And from there, you can think of a research focus, like what exactly are you going to hone in on? So from there, you want to find an open question or something that hasn't been solved in the field, and you want to get to it, right? And at that point, good luck, because then that's just the start of the research process, where you just have to read papers, develop a good method, make sure that it works, and essentially collect results or collect data, collect results, and then verify that your method actually makes sense and evaluate your results from there. So if you are interested in finding research here, Here are some ideas. So you can take CMPM 15. Personally, I haven't, but I think it's a pretty good idea if you want 5 credits and are interested in research, because I've heard that it's a very, very good class in just getting exposed to what's going on the campus and research and such. So do consider that. If you want to cold email professors, that is historically a way that many people have done so. But I must warn you, professors often do not like to be bothered, even if they don't say so. A lot of professors here on this campus are quite friendly, but if you really, really want to work in a lab or do anything in a lab, do research, you have to make sure that you know exactly what you want to do. You have to you have to do your homework. You're going to want to read their work. You're going to want to read like several survey papers about the subject. You're going to want to know like your stuff and explain, okay, A, B, C, what do you want to do? I want to do this and that because this and that and that. You want to be able to explain why you want to join a professor's lab if you're going to do so. Otherwise, it's kind of a waste of time for both you and them. Because if they have to take the time to get you up to speed, it's a time sink on them too. So you got to make sure that what you're going to do is worth it, that you really want to do it. So yeah. So if you're going to email a professor, make it easy to understand, make it short, as I just said. Good writing is short and sweet and easy. So yeah. Clicker. No. Yeah. So here are a few professors. They have a lot of undergrads in their labs. So I highly recommend that you find other professors, but I'm sure that these professors, if you demonstrate that you're really interested in their work, if you're really interested in their work, they will probably let you do something under a PhD student or a master's student with them. So Professor Ashragian, he specializes in neuromorphic computing and hardware, which entails working with spiking neural networks. I'm sure Dylan can tell you more about that. Professor Gilpin, she's among other things. She does a lot of things, but her main projects, or some of her main projects here, are autonomous vehicles and explainable AI in general. And Professor Marinescu, he does a lot of things in related to medical machine learning. But one of his main projects is molecular dynamics, more specifically the simulation of a cell. That's one of his main goals. So if you find that interesting, I don't know, maybe read more of his stuff. But I strongly encourage you, if you're interested in research, to look up more professors, and see what they're doing, and see what their PhD students are doing, and what projects they've got going on, and what work they've done. Because I can assure you that there's probably something interesting happening here that you'll find very stimulating.
I also want to mention on this topic, we are going to be getting a lot of new AI faculty, I think, at the end of next year or this year. So starting this summer, there's going to be a big hiring for new AI faculty. And oftentimes, new faculty are going to be the best people to do research with. This is because they are still exploring lots of new research topics.
And they're desperate.
Okay. Mainly, they're still exploring more research topics. They have a lot more energy to put towards undergrads. So if you go to some of the kind of professors who have been here for a little while and you get into their research, you probably won't be interacting with them as much. That goes to the same thing as these professors. These are relatively new professors, but they are the professors who are most vocal about wanting undergrads. So it's going to be relatively easy to get into their labs, but you might not see them or interact with them much, which as an undergrad, if you can do some research where you're directly working with the professor, that's going to be invaluable. So what I'd recommend is actually either look up some of the current AI professors who are here and who aren't mentioned a lot, who don't advertise their research a lot, and email a bunch of them, or wait until we get this new hiring spree, and you might get lucky and find a professor who's really interested in hiring undergrads, but also doesn't have that many undergrads in their lab yet. That being said, as far as practical applications go, while I have the mic here, I wanted to talk about the Gen AI. What's the term for it? The thing that's being like that they've been working on building. It's a group of faculty members. I think it's about 20 professors have been working on creating this generative AI group here at UCSC. It's been around for a while. They do talks and they invite anyone to come to said talks about kind of what they're doing, et cetera, et cetera. I can send a message about where to find out about these in the Discord. But it's this group of professors that's forming, and they are actively looking for ways to spread to the student body. So if you, as a student, as an undergrad student, are interested in that kind of research, I would encourage you to go to these professors because they will be looking to you as a resource for connection to the rest of the student body. And becoming a integral link between a professor and their access to the student body means that you are important to them and therefore will get lots of opportunities like research, et cetera, et cetera, et cetera. So that's something to keep an eye out for. A lot of this stuff, getting involved with research, talking with professors, et cetera, et cetera, et cetera, will be a little difficult if you don't have any projects under your belt yet. And when I say projects, I don't mean end goal, I'm publishing this, I'm making a website, et cetera, et cetera. Some kind of neural network, some kind of AI thing is usually good enough so that they can look at it and go, oh, you know what you're doing. So if you've done some projects like through Sky's No Limit or through some other process or even on your own, it'll really help you get into these labs and start working quickly. There will be a lot of reading papers as you get started, as Eric mentioned on, I think, the previous slide. The first thing you do is you read a bunch of papers and you understand the topic. But yeah, then if you have some projects under your belt, it will help you get into this research and stuff like that. As creating a project on your own is possible, but it requires a lot of other stuff. So if you're interested in web dev, if you're interested in application development, et cetera, et cetera, et cetera, that's a great place to go into. But if you're mainly interested in ML or AI, it may not be worth your time to try and create a whole fully fledged website or app, in which case research might be the better option. Yeah, I think that's all I have to say. So I'll give it back to Eric.
I completely agree. In general, I would highly, strongly recommend if you want to get a good start with messing around with ML stuff, definitely check out Sky's No Limit next quarter, or maybe even now, because we've still got a week to submit something. So maybe if you make an ML model right now, you can probably I'm just saying. Yeah, yeah. Ah, it's all right. Hmm. Well, submitting something is better than submitting nothing, I'll just say. But yeah, I think that's about it. Are there any questions or anything? I don't know. Okay. Right now I'm working with a master's student to where's my notebook? I need to get my notebook out for this. Oh my goodness. Well, I'm not here to make elevator pitches to people. I'm here to like try to publish it like soon. But that's true. So basically we're trying to be able to establish a hierarchical structure of challenge levels for data sets to evaluate LLMs. Basically, what we're doing is trying to make a good quantitative benchmark for how difficult a data set of, let's say, math questions is for LLMs to answer correctly. And on top of doing this, we want to figure out, this is like very early stages, this sentence. We want to figure out how to get LLMs to develop the ability to learn progressively from these data sets. So maybe if we have put in very easy questions at first, it'll perhaps learn over time how to better answer the hard questions. So that's our method so far. But I am kind of prodding the master's student I'm working with towards stuff that's more interesting. Um, I mean, I obviously the method we still have will be intact, but I have found quite a few papers that are would be interesting to use in the course of our research. Um, yeah, uh, that's that's our research so far. What I've been doing is just lately automating pipelines just to evaluate multiple LLMs on the lab computer, um, so that we can just like get the experiments out of the way quicker. Not really glamorous, but I find it interesting. So yeah. Kevin, what do you do?
I work in Professor Marinescu's molecular dynamics lab, which means we are building machine learning models to try and simulate proteins. So if you've ever seen a protein simulation, it's a little chain of atoms and molecules, and it wiggles around and it folds and it attaches to other proteins and it disattaches from other proteins. And simulating these is extremely computationally expensive. And we are trying to make ML models to speed that up tens, hundreds, thousands of times so that eventually we can simulate just, toss some kind of drug in a simulation with a cell and see what it does. Because currently that would take about few hundred years of computation per frame. So we're trying to make it so that that's actually a feasible method of research for discovery of new drugs and testing of that kind of stuff.
Oh, yeah, how fascinating, right? I find Kevin's project really fascinating. But anyway, if just to get it off the top of my head, if you do intend on joining a lab, make sure you have your basics very well covered. So definitely know how to use Git well, know how to use Linux, know how to use just know Python in general. Please know Python quite thoroughly. Um, do know basic data analysis. Well, perhaps you won't be doing too much data analysis, but like it's good to know. Like so, knowing pandas is good. Knowing matplotlib is good. Definitely know NumPy. Obviously, know PyTorch, as yeah, everyone uses PyTorch. And yeah, that's about it. Also, another part of the Yap session that I have. So what I did with a team of friends is what I did was I implemented just ChatGPT 4.0 in a website that we have called StudyKit.app. StudyKit. There's no space. You can look it up right now. It's got like I think around I think total global users is like 100,000 50,000, something like that. But yeah, we implemented ChatGPT, and basically my method or purpose was like, hey, we can use ChatGPT to really like evaluate how well students are doing, like how well like they if they put in the topics they have as flashcards, we can analyze that, and using ChatGPT, we can feed it into a prompt and say, hey, ask a free response question based on what they've been doing, and evaluate it on a scale of like 1 to 5, how well or how poorly they answered it. And it's one of our most popular features, actually, which I'm quite happy about. Yeah, so that's a very personal example of how you can use AI, or specifically OpenAI API, to do something useful for users that hasn't been done before. Um, yeah. So yeah, that's about it. I don't know. Are there any questions or anything or any comments? Yeah. Yeah. Thank you. I'm Eric. Yep. Fun times.
All right. Well, thank you everyone for coming. We think yeah. Thank you everyone for coming. Our next meeting will be the Sky's No Limit presentations. So some of you guys are going to be presenting the stuff that you've made. Even if you're not presenting, please come by, check it out. You'll get to help vote. See who gets to win. And yeah, I hope to see everyone then. If you have time to fill out the feedback form, we'd really appreciate it, because we are looking always for more topics to cover. Never mind. Okay. Well, if you have any ideas for stuff you want to see us cover, spring quarter is a lot more freeform. We have a lot less stuff kind of planned, which means we have a lot more wiggle room for things that you guys want specifically to cover. So if you're like, hey, we never did diffusion, I'm curious how that works, can you guys talk about it? Come let us know and we'll see if we can incorporate it. I know all of you guys who are here right now come frequently enough to the meetings where if you want something to be covered, we can probably make it happen. Yeah. VAs? Yeah. Yeah, we could totally do that. Eric, can you write that down somewhere? Thanks. Cool. Yeah. So yeah, stuff like that. We'll be doing some more general stuff. And then we'll also be opening officer applications, I think, at the beginning of spring quarter. So if any of you guys are interested in becoming officers, you guys all show up relatively frequently. I recognize all of you guys, so you've got a pretty good chance if that's something you're interested in. We'll be planning out some big plans for next year as well. And yeah. Any questions? Okay, cool. Thank you, everyone. We'll go ahead and end it here, and yeah, we'll be here for a little bit as the recording saves. And have a fantastic evening, rest of your guys' day. Thanks. All right. Let's end this. Where is it? There.